let's look at convex mirrors because we've looked at concave mirrors up to now. So convex mirrors, the maths behind them is very similar to the maths behind concave mirrors. It's almost exactly the same. And if you were to look at a simple sort of example of a maths type problem that comes up for convex mirrors, it might go something like this. So in the problem, it would say that a convex mirror with a focal length of 25 centimeters. Now, we need to be a little bit careful with convex mirrors. Although they're simpler in some way, we just have to be a little bit careful with them. So there's my convex mirror with my silvering on this side. Usually we'd place an object over here. And over here somewhere is where your focal length is, your focal distance, because it's halfway between the center of curvature and the mirror itself. So here's my focal distance. We had a convention all the time so far that over here is the positive side. So anything that's on that side of the mirror will give you a positive value mathematically, and on this side of the mirror will give you a negative value mathematically. So if you notice, the focal point is on the negative side of the mirror. So our focal length is always going to be negative, and that's the only thing that we need to keep in mind realistically for convex mirrors. The other thing that makes life easier for us in some ways is that in a convex mirror, you will always get, regardless of where you put the object, you will always get a diminished virtual image that's upright as well. So you'll always get a virtual image, which means a v will always be negative as well. If you finish the problem that you're trying to, where you're trying to calculate something, and you get a positive value for f, or you get a positive value for the for v, then you need to go back and check the question again and check your solution because it may not be correct. Okay, so in this example problem, the question tells you that the focal length of the convex mirror is 25 centimeters. So we need to know from our own knowledge that f is equal to minus 25 centimeters. F is equal to minus 25. So we'd keep that positive for a concave mirror. For a convex mirror, it's negative. And then an object is placed 45 centimeters away from the mirror. And the question that we're asked for this is, what is v? So what's the image distance? So what's the image distance? V equals question mark. And what's the magnification? Now we should expect, because we always get a diminished image, we should expect a magnification that's greater than 0 but less than 1. So it should be a fractional value. And it should be negative because it's a virtual image. Okay, let's have a go at the solution to this. So 1 over f is equal to 1 over u plus 1 over v. We start with the same formula as ever. But now we're going to sub in some negative values in here. So this is going to be minus 1 over 25, because we'll put in the 25 in for f, is equal to 1 over u, which is 45, 1 over 45, plus 1 over v. And we're okay to keep this positive because so far, because of the way that we're using the equation, what will happen at the end is we should get a negative value for v at the very end. So let's keep going with this and see if that's what happens. Now, I'm going to subtract 1 over 45 from this side in order to get rid of it, because it's added to the 1 over v. I want the 1 over v on its own. So because it's added on, I'm going to subtract it from this side, and that will cancel it away. But I also have to subtract it from this side because it's an equation. There's an equal sign there. So minus 1 over 25 minus 1 over 45 is equal to 1 over v. Right, I'm going to just flip these over to the other side of the equal sign to make that easier, because some students prefer that. 1 over v is equal to minus 1 over 25 minus 1 over 45. Okay, now I have to get a common denominator. So 1 over v equals, and if I look at these, 450 will work, or 225 will work as well. They'll both go into 225. So 225, we've got a minus sign here. We've also got a minus sign in front of this. 225 there as well. And if I divide 25 into 225, that's 9, and 9 times 1 is 9. And if I divide 45 into 225, I get 5, and 5 times 1 is 5. So now we get 1 over v is equal to, I've got minus 9 minus 5 is minus 14 over 225. And this is looking right now because I want a negative value at the end, and I've got a negative value divided by a positive value here, so that's looking good. V is equal to, I have to do the reciprocal on both sides, 225 over 14, but I've got a negative sign in front of that. And then in order to answer this, I'm going to go to the calculator. So 225 divided by 14, and I get 16.07. So we'll take 16.07 centimeters. Negative value here. We can't forget the minus sign. So this is telling me that I get a virtual image at 16.07 centimeters behind the mirror. Now, the next thing we're asked about is the magnification. So let's look at magnification. M equals question mark. Well, M equals V over U. So I have U is 45. So I can do V, which is 16.07, divided by 45, like that. And this is a negative value, but I'll handle the sign on its own. Divided by 45, and it comes out as 0.36, so minus 0.36. No units on the end of magnification because it's just a certain number of times. In fact, it's centimeters here divided by centimeters, so your units go away. So minus 0.36. The minus sign here just tells us that it's virtual. And the fact that this is between 0 and 1 means that this is diminished, as we expected. So the values look right because I've got a negative value for V, which is correct. I've got a negative magnification, and I've also got a small magnification. This shows that this is a diminished image. Okay.